Today we are going to look at calculus, differentiation actually, and that branch of the method that we're going to use today will be implicit differentiation. Why do we have to use implicit differentiation? They said we should differentiate this function with respect to x. Now, when we say differentiate with respect to x, it's also the same thing as asking to find the y over the x or the x. Now, if they are asking us to differentiate with respect to x, it means that y must be on its own. Differentiate y with respect to x. Y must be on its own, and everything on the x must be on the other side. There must not be an element of y on the right-hand side. Now, this is what we do. If it's just normal function or expression, when we simplify, we can make y the subject formula and every other thing moves over. Now, let's see if we can actually do that. If we have xy here minus y cubed is equals to 8, and then this becomes minus x to the power of 4. Now, we can factorize this. If we take out y, we have x minus y squared equals to 8 minus x to the power of 4. If we still look at this critically, we see that even if we divide both sides with the coefficient of y here, we still have an element of y on the other side. So this will not work. So if this cannot work, we use the implicit method, which means differentiate each section separately. Differentiate each section separately with respect to y. So what are we going to do? Let's look at that expression. We differentiate x to the power of 4 on its own. We also differentiate xy on its own. We also differentiate y cubed on its own. And we also differentiate 8 on its own. We differentiate 8 on its own. Now let's go forward. Now, derivative of x to the power of 4 with respect to x will be 4x 3 minus 1. So we have 4x to the power of 3. 4 minus 1 is 3. Now, we have a problem here. This is xy, x times y. So we cannot differentiate. It is not addition or subtraction. They are not two sections, they are multiplied. So we can only apply the product rule here. And product rule says, if I have f times g, two functions, that the derivative of f times g will be first derivative of f times g plus first derivative of g times f. So this is what we have as our product rule. So that is how we are going to differentiate that. So we are going to break down x and y. So we are going to have derivative of x times y plus derivative of y times x. That is product rule based on what we have here. And then minus differentiate y cubed with respect to x. That is not possible. So if we differentiate, we'll still put the y over the x to show that we didn't differentiate with respect to x. So we have derivative of this. Y cubed is 3y squared, but we will still have our dy over the x, showing that we didn't differentiate with respect to x. Then the derivative of a constant is 0. Derivative of a constant is 0. Now let's go on and complete this. We have 4x to the power of 3 plus derivative of x is y. So we have 1 times y plus derivative of y. We are differentiating with respect to x. So we will have derivative of y is 1 minus 1 is 1, but we have the y over the x because we didn't differentiate with respect to x. And we also have our times x. Then minus 3y squared, and we have the y over the x. What do? We simplify by collecting items. We simplify by collecting items. So everyone that has dy over the x attached to it, we put it on one side and the other one goes over. Now, this is what we are going to have. We have x dy over the x. So if we have x dy over the x minus 3y squared dy over the x. Equals to, let's take every other thing over. This is 4x cubed, going over becomes minus 4x cubed. This is 1y, going over becomes minus y. So we have taken it over, and then we make the x over the y the subject formula. Now, if we factorize the left-hand side, we have the y over the x, and then the factors here is x minus 3y squared equals to 4x cubed minus y. Now, the next step is to divide both sides with the coefficient of the function, which is the derivative. So we have x minus 3y squared. If you check, may not be simplified, but this will be the derivative of this given function if we use the implicit approach to differentiate. Remember, under the implicit function, you can get your product rule, it can be quotient rule, it can be anything that can pop in. Before you get to this level, you must have gone through quotient rule, product rule, chain rule, and the rest of them. But if you cannot simplify and y stays alone, becomes a subject formula, then you have to use the implicit differentiation approach. Please, if you have any query, do not hesitate to ask. I'm here to support and to help us go through this. Please, this is the derivative of this function using the implicit approach. Keep on studying, keep on sharing, subscribe, and follow my pages. I will see you. Have a blessed day.